Here's question number 2. Suppose our function looks like this: x to the power of 4 minus 32x squared plus 3. Part A. We want to find intervals where the function is increasing or decreasing. If you remember from the previous lecture video, we need to find out the most important point. It's called the critical numbers. In order to find critical numbers, we have to find out the derivative. Our goal is to find the x value when the derivative is equal to 0. If you take out the GCF, which is called the greatest common factor, we get this, and then you can factor this further as well. This means we have 3 critical numbers: 0, positive 4, and negative 4. Let's move on to step number 2, because we want to use the number line to test whether the function is increasing or decreasing. Now we have proper number line, and hopefully you know how to do this from now on. If you watched the video earlier, you can plug any number less than negative 4, say negative 5, and plug that number into our derivative and check whether it's plus sign or minus sign. And then you can try any number in between negative 4 and 0, say negative 1. And then try any number in between 0 and 4, say positive 1. And you can try any number greater than 4, say 5, and plug it into the derivative. And you have your calculator, plug that number here, plug that number here 4 times, and check whether it's positive or negative. Let me show you with my Maple calculator. Looks like, everyone, I have negative number, which means this is negative. And then the next one is positive. And then the next one is negative and positive. So this shows whether the function is increasing or decreasing. This minus sign means the function is decreasing. Something like this. This plus sign means the function is increasing. Something like that. And then decreasing after 0. And then increasing after 4. Something like this. So f is increasing on the intervals negative 4 to 0, union 4 to 5. Sorry, 4 to forever, which means 4 to infinity. F is decreasing on from forever left, which means negative infinity towards negative 4, union from 0 to 4. Thank you, everyone. This is the answer for number 2A. So for part B, we need to find the local minimum and local maximum of f. Honestly, if you look at the number line, this tells you all the information that you need. Look at my black color curve over here. It's decreasing, and suddenly after negative 4, it's increasing. So tell me, do you think this point is local minimum or local maximum? If you said this is local minimum, then you're correct. You always have to follow this format, please. Whenever we say local minimum value, we mean y value, not the x. So local minimum value of some function value at negative 4 at x equal to negative 4. How do you find this one? Basically, plug this number into the original function, please. And I get negative 253. Now, in order to answer local maximum, it's happening at 0. The y value when x is equal to 0 becomes just a constant term, 3, because 0 minus 0 is just 0, plus 3 is just 3. And lastly, did you notice that we have another local minimum over here at 4? At x equal to 4, we also get negative 253. Anyways, everyone, if your web assigned question asks you to find local minimum value, that means you have to find out the y value. Local maximum value, you have to find out the y value. So you have to plug this number and this number into the correct position, please. Now we're done using the first derivative. In order to talk about concavity, we just have to find out the derivative one more time and do exactly the same thing. Part C, we want to find intervals where the function is concave up or concave down. And then we're going to find the inflection point. Remember everyone, whenever we are trying to discuss about concavity and inflection points, we need to use the first derivative and find the second derivative. So if you remember from before, we found out the first derivative is 4x cubed minus 64x, and its derivative is 12x squared minus 64. That's our second derivative. So let's solve this equation. To solve this equation, basically we solve for the x. It's basically x is equal to plus or minus 4 over square root of 3. And everyone, these are the critical numbers for the second derivative. Using these critical numbers, we can find concavity and then the inflection points. Everyone, to find all the information you need, such as concavity and inflection points, the game changer is to have a very good number line. And then mark down all the second derivative critical numbers. And then you can plug it in any number less than this. So 4 over square root of 3, let's find out the decimal number for this fraction here. About 2.31, this means we need to pick up a number less than negative 2.3, say negative 3. If we try f double prime of negative 3, we get positive. If we try f double prime of 0, plug it into our second derivative here, then surely we get negative. Next, you can choose 3 or 4, whatever number you like, which is greater than this fraction. Say 3, f double prime of 3 is again positive. Now we can answer the concavity and then the inflection point. F is concave up, which is positive, right? Concave up from 4 over left towards negative 4 over root 3. That's this interval here. Negative infinity to negative 4 over square root of 3. Union 4 over square root of 3 towards infinity. Let's talk about the concave down. F is concave down in between this number and this number. Finally, everyone, in order to talk about the inflection point, you just need to check. At x equal to negative 4 over root 3, concave up becomes concave down. So this point gives us inflection point. And once again, on the left-hand side of this point, it's negative. Right-hand side of this point, it's positive. Therefore, this point is called inflection point as well. So what is the y value for this corresponding x values? It is negative 1,253 over 9, or you're welcome to use a decimal number if you like. Both y values give negative 1,253 over 9. Thank you, everyone. Concavity, inflection points, local minimum maximum, and then increasing decreasing intervals, everything we found using derivative and then the number line. This kind of technique is called the first derivative test. Thank you, everyone. This is the end of question number 2.